What I want to show here is something called thin film interference, and I've already set the diagram up here a little bit. We've got these two mediums, N1, N2, and N3. N3 could be the same medium as N1. Main thing being that this is a denser medium, it could be a thin film. This could be air. So we've got a ray coming down here, and what's going to happen is it will reflect at A. But it can pass into the film. Being denser, it bends slightly towards normal, and then it reflects again and shoots up here. Now, basically what we're going to see is that, and if these angles are quite small, then what we're basically saying is that the path difference is approximately equal to 2L. And we could then relate that to the wavelength and say, okay, if we get a path difference that's equal to, because obviously these guys hit in phase, if this one then has a path difference, if the 2L equals an even number of wavelengths, then we could say there's constructive interference, and between A and C, and here, it would then look bright. So you see this in films, sort of like detergent films, and you often see the different colors, but the different depth regarding, so this has obviously got to be an L that's close to the wavelength of the light we're talking about. So if you get the constructive interference, this becomes a bright fringe. If it was not, if there's destructive interference, then this little area in here would become dark. Now there's a few things to consider here that are of interest, which is why it makes thin films worth looking at. When we count the number of wavelengths in this gap, we've got to remember that now this is a different refractive index, so the wavelength actually changes. So the wavelength inside this medium here is actually going to be, so we've got a new wavelength, which is going to be wavelength in N2, if you like, is going to be equal to the wavelength on the outside divided by the refractive index of that medium, N2. That's something we did in level 1, I suppose, that type of thing. So the wavelength actually changes. Now, so that's the first interesting thing to take into account, because otherwise we could just be going, okay, 2L's got to be equal to an even number of those wavelengths, the wavelength in N2, this one that we just defined. But it's even more interesting than that, and this brings in the other aspect of waves, which is that when something does its reflecting, if it's entering a denser medium where it would travel slower, then when it does that, there is a phase change. This is the old pulse going along a rope, and then suddenly it's going into a thicker rope. It's going to travel more slowly, but it's going to come back along this rope upside down. That's a phase change. So in reflection, remember, when you're going into a denser medium, you get that phase change. So this is a denser medium, so this one's already out of phase with that one. And how much out of phase? It's out of phase by pi. So we've already got a out of phase relationship by pi, and then we've got the number of wavelengths in here. So what we can now say is that if the number of wavelengths in here, okay, equals half a wavelength difference, then combined with the phase change, we're going to have constructive interference. So we actually can say 2L must be equal to m plus 1/2 times the wavelength inside that medium, which was that wavelength, n over 2, or we could just write it as the normal wavelength over n2. So that would be constructive interference. All right? And if we were looking for destructive interference, because it's already got that phase change, then we'd want the full number of changes, if you like, which would be where we can say 2L equals m times the wavelength over, 2L over n2. That is the normal situation where we normally got constructive, but because of the phase change at the reflection, this is where we'd actually get our destructive interference, and we would call that a minima interference. So that's our maxima, that's our minima. So it used to be in the syllabus, not now, but worth knowing about.